And on page 56, I'll give you some time to write this down. This was on one of the very first final exams that taught this material. And we're going to go through an algebraic way of solving this, look at some of the pitfalls on this exam and why this wasn't necessarily the best question, but how we could solve it. A box is in the shape of a rectangular prism, has lengths of x, x plus 2, and x plus 10. So we could draw it out. X, x plus 2, and x plus 10. So often a visual really helps us solve something. Write a function volume in terms of x. So our volume function is length times width times height. This, by the way, was on the non-calculator part of the exam, which made it more problematic in some ways, which we'll find out. So there is the first mark in this question, writing out the equation. Find all possible values of x given that the volume is 96. So if you know the volume is 96, you could put in 96 in here. And then says find all possible values of x and state the dimensions of the box. Now this is where the problem came into the question for most students. Because it was non-calculator, students knew that x couldn't be something crazy like 1.37. So we have three numbers that need to multiply to 96, and it didn't take very much guessing and checking, and most students found out that x equals 2 works. Now the problem with the way this question was worded and with how the exam was marked is students who just wrote that year got 40% on the question, 2 out of 5. They got the right answer, they checked it, it worked. Part of the problem was by guessing and checking, you're not sure if you found all the possible solutions. There might be more solutions, even though in this case there are not. That is the only solution. In order to find all the solutions, you would need to do an algebraic approach to this. So an algebraic approach. And so now this same question, if it shows up on the exam, they often add find algebraically, which takes out the plug in and answer and guess and check. Find algebraically all possible values of x. And if you were finding it algebraically, well, that's when you would have to solve this. Now, you can't just say the answer is here because it's not equal to 0. So first of all, you would have to multiply this out. Maybe I'll multiply these first. And then I'll FOIL this out. 2x squared plus 12x squared. And after multiplying out, only then can I move things over and make it equal to 0. Now, if you're solving an x cubed equation and it's equal to 0 and it's non-calculator, you have to factor, which is also problematic in this question, because if I was checking to see which numbers work to help me factor this, mental math-wise, can you see the factors could be 1 and 96? How many of you know 96 cubed? Try the factor theorem. No, right? So it's a little problematic because it's not all of the answers you could actually check without the calculator. But if you let p of x, that's too many brackets, but that's okay. Let p of x equal that, and since you already, or we've already guessed and checked that, 2 works, plug in p of 2, and sure enough, it's equal to 0.
What if you don't guess and check?
Well, a couple of things that could help you with this. For 1, you would never check negative values of x. So I'd never check negative 1. I would never check negative 2 because the context of the question is a box where one side is x, and obviously x can't be a negative number. Okay? So I would have probably tried 1 first. And quick mental math, 1 plus 12 plus 20 minus 96 doesn't work. And then try 2 next, and so on. And then now that we've found out that p of 2 equals 0, this means x minus 2 is a factor. 1, 12, 20 minus 96, and a 2 outside. Bring down the 1, 2, 14, 28, 48, 96, yay, 0. So now we can rewrite our equation. 0 is equal to x minus 2 times x squared minus 14x plus 48. Notice I didn't write p of x equals because my original equation that I'm coming from had 0 equals, and I'm trying to solve it. So I wrote 0 equals again. And now we can check, does this factor? Two things that multiply to 48. Sometimes this won't even factor, and you can just make a little note, can't be factored. Or use the quadratic formula to see if there's a reasonable result. Yes, thank you. The 14x is positive. Then you might lose a mark for that, because there might be a reasonable answer that is.
Do you have to plug everything that you know that you can't factor regularly? You have to plug it into the quadratic formula?
If you can't factor it regularly, then you'd plug it into the quadratic formula. In this case, this one does factor. It's going to be x plus 6, x plus 8. Okay, so we have 3 possible solutions. However, given the context of the question, these two don't make sense. You can't have a side length of negative 6. You can't have a side length of negative 8. So as someone who, when this was for the first time on a final exam, and seen so many students getting 2 out of 5 with the right answer. Okay, so now this was a word problem. You need a final statement. The dimensions are 2 centimeters by, what were the other numbers? X plus 2, 4 centimeters by 12 centimeters. Because the question asked for the dimensions, right? If you didn't include units, units are an E5. If I go back to the picture of my box that I have there, x, x plus 2, x plus 10. So if x is 2, then this would be 2, 4, and 12.
So you'd find if there was more than one, you would just find it in the factors?
Yeah, so these, if there was another possibility, it would come up there. Hardly, almost no one. So it seemed a little bit unfair that way. Now they've added the word algebraically, which I don't know how much more fair that makes it. Okay, but...
They can tell you to use algebra all you want, but if you don't know how to do it...
Well, and so this is... This is the part here at this step. If you want to solve something like this, this idea that you need to make one side equal to 0, here, let's start up here actually. right? I want to solve, no, right up here. There we go. I want to solve this. It's already factored. It looks like it's not going to be much work, but the side has to be equal to 0 in order for factoring to solve to work. And so we had to expand everything just to get the 96 over to the other side, just to refactor it again. So it is a fair bit of work to get it to a place where you can factor it. And it's a little bit problematic because we're lucky that a small number, which you could do mental math with, worked, because anything bigger might not have worked. Okay? These questions are difficult to make that have something that, like this one, factored nicely. After this, I've seen questions, most often this part of the question then ends up not factoring nicely, and you have to use the quadratic formula. So be ready for that on your test for Thursday. Something that maybe this doesn't factor. I think on our vertical whiteboard activity that we did, the very last question that people did in this, remember you spent a lot of time on it and it didn't factor. So I need to give you more practice with ones that don't factor so you feel confident saying, I'm done.